Good day everyone. Our topic for today's Mathematics 9 will tackle about discriminant, sum of the roots, and the product of the roots. Our objectives are: number 1, determine what discriminant is. Number 2, apply the concept of discriminant to determine the number of roots in a quadratic equation. Number 3, recognize the formula for sum of the roots. Number 4, apply the formula for the sum of the roots. Number 5, recognize the formula for product of the roots. And number 6, apply the formula for the product of the roots. Now, let us recall that this equation is the quadratic equation in standard form. And these variables, a, b, and c, are any real numbers provided that a is not equal to 0. This variable, x, is called the independent variable, and it can be solved by several methods such as factoring. We can also use extraction of square roots, completing the square, and lastly, quadratic formula. And the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, wherein the quantity inside the square root sign, which is b squared minus 4ac, is called the discriminant. But what is discriminant? Given a quadratic equation in the form ax squared plus bx plus c equals 0, where a, b, and c are any real numbers and a is not equal to 0, we can determine the number and type of solutions of a quadratic equation by evaluating the discriminant. This is the purpose of discriminant, to recognize how many solutions are there in a given quadratic equations. Number 1, if your discriminant is positive or greater than 0, the equation has two real solutions. The roots will be rational if the discriminant is a perfect square, otherwise, the roots will be irrational. For number 2, if your discriminant is exactly 0, the equation has only one real solution. And lastly, if your discriminant is negative or less than 0, the equation has no real solution, and complex number will exist. Let's have an example. Use the discriminant to determine the number of real solution of 16x squared minus 8x plus 1 equals 0. For the solution, let us recognize first the values of numerical coefficients. Here, a is 16, b, negative 8, and c is positive 1. By discriminant form, b squared minus 4ac, all we have to do is to directly substitute the given values to our discriminant form. So we have negative 8 raised to 2 minus 4 times 16 times 1. Simplify, negative 8 raised to 2 is 64. Then negative 4 times 16 times positive 1 is negative 64. So 64 minus 64, that will be 0. Since our discriminant is 0, property number 2 satisfied. As a conclusion, since discriminant is 0, the equation has only one real number solution. Another example, use the discriminant to determine the number of real solution of x squared plus 2x plus 3 equals 0. So for the solution, first, let us recognize the values of numerical coefficients. Here, the numerical coefficient under the term x squared is 1. For b, that will be 2. And for c, positive 3. By discriminant form, b squared minus 4ac, substitute, we have 2 squared minus 4 times 1 times 3. Simplify, we have 4. Negative 4 times 1 times 3, that is negative 12. And 4 minus 12 is negative 8. What is the conclusion? Under number 3, since our discriminant is negative, the given quadratic equation has no real number solution. Let us have another example. How about 2x squared minus 3x equals 4? This given quadratic equation is not in standard form, so we have to convert this first. By doing that, let us add -4 both sides, or we can subtract +4 both sides. Then, we will obtain this one. 2x squared minus 3x minus 4 equals 0. Here, we can now determine the values of our numerical coefficients. First, a is 2, b is -3, c is -4. By discriminant form, which is b squared minus 4ac, as usual, let us substitute the given values. We have quantity -3 raised to 2 minus 4 times 2 times -4. By simplifying, we have +9 and +32. So, performing the operation, 9 plus 32, that is 41. And 41 is a positive number. Property number 1 satisfied. 41 is not a perfect square, so your root will be a irrational. Since the discriminant is 41, the equation has two real solutions.